Hello, Professor Zawolo. Today we're going to be going over subsection G, which is set of the number and numeration, section A of the West African Examination Council Senior Secondary School Certificate Examination, Mathematics for Liberian Schools. In this video, we're going to be covering the objective, recognizing sets, set notation, symbols, defining infinite and finite sets, subsets, union, and intersections of sets. A set is a well-defined collection of objects. Okay, we have a set of students, a set of vegetables, a set of books. All those things are set. So the things that make up a set, the components of a set, we call them the elements of the set. And there are several ways we can show a set. We can show a set by listing the elements of the set. Like over here, we have this set here, A, containing 2, 4, 6, 8. So we can list the elements of a set. Well, another way we could do a set is to use what we call a set builder method. So we don't actually list every element. We do some kind of symbolic representation of the elements of the set. For example, we say A is a set X such that X is an even integer, okay, and X is between what? 0 and what? 10. So the even integers between 0 and 10 will actually be what? 2, 4, 6, and what? 8. So this is basically the same set, it's just that it's defined differently. Another way we could define it is X is even integer between what? 1 and what? 11, which will be again 2, 4, 6, 8, 10. 2, 4, 6, 8. 10 in that case. Good. Now, when a subset is a set which has all of its elements as a part of another set. So A is a subset of B because every element in A is also in B. In A we have 1, we have it in B. We have 2, we also have it in here. In A, we have A and small a here. So A is a subset of B. We say A is a part of means subset. So one way we can show an empty set is by using the symbol as 0 with a slash away, or just writing the set. Using the set, the braces, but with no element in it. Now, one of the things that some students will try to do is to indicate an empty set like this. This is wrong. You have to just keep it open like that without any element in it. So, what is a finite set? A finite set is a set whose elements can be counted. You can associate each element of that set with a real number, with an integer, a positive integer. So a set that is countable. An infinite set is a set which is not totally countable. For example, X such that X is an odd integer. We have infinite number of odd integers. Therefore, we say set C is infinite. Whereas the number of odd integers between 0 and 10 is finite because you can count them. Unions of sets. Whenever a union of two sets, A and B, which we write like this, is such that A, we kind of wrote some things here. That the union of two sets, A and B, written as A union B, is such that either X is in A or X is in B. So let's write this off here. Either X is in B or X is in A. And it's defined as the set of all elements in A, B, or in both A and B. So here's a symbolic representation of a union. X such that X belongs to, this means belongs to, or is a member of. So when we say here X belongs to A, or X belongs to B, or X belongs to both A and B. That's what we call the union of sets. Okay. Now there's another concept. So this is how we can graphically, schematically show a union. So if we have two sets A and B, and then we have the universal set here, which is a rectangle, then the union of A and B would be everything that is inside A, B, or in both A and B, as you can see between here. Intersection is basically the overlapping portion of two sets. Okay? So the intersection of A and B is the set of elements that are in A and also in B. Okay? Now here's a representation. So you have these two sets, A and B, the universal set. The intersection is this colored area here, where the sets overlap. Then we have a concept of complement. So when we talk about a complement, we'll go back to the universal set. The universal set is something like a universe, and the complement of A will be those elements which are in the universal set but are not in A. See, X is such that X belongs to the universal set, but X does not belong to A. So for example, say if I have a universal set, let me just do this. 1, 2, 3, 4, 5. This is my universal set. If I define A to be the even numbers here, I have 2 and 4. Then A prime, the complement, will be those elements which are in this universal set but are not in A. What are these elements? 1, 3, and 5. Now, what I'll also say to you here, let me give you another important concept, that A union A prime will just equal to U. So it will form the union of the complement and the set, we just get the universal set. So here's how we can show a complement. If this is set A, then the complement of A will be those elements which are in this universal set. They color the rectangle, but are not in A. So everything outside of this circle within the rectangle will be the complement of A. Disjoint sets. Two sets are disjoint if you have nothing in common. For example, if I have set A to be those even numbers between 1 and 10, so that's 2, 4, 6, 8. And then I have B to be the odd numbers. So I have 1, 3, 5, 7, and 9. Now, these two sets don't overlap. So A intercept B will be disjoint. They do not have anything in common. Now, so we can show two disjoint sets here like this. You see that set A and set B do not overlap. So, yes, a first problem we have to do here. It is taken from the WAEC Liberia 2010 is problem number 11. Let's have a look. If W is the set of integer X such that X is greater than 4. So let's go to W. W is such that it's an integer. It has to be a positive or negative whole number. So, but it's an integer that's greater than 4. So what are integers greater than 4? 5, 6, 7, 8, 9. In fact, I'll do 10. There's a reason I'm doing 10. I'll do a couple more because I want to show you something. 9, 10, 11, 12, and you can go on forever. Because these are all integers that are greater than 4. Now, integers means whole number, negative and positive. But integers will be negative and positive whole numbers. But not, yeah. So now, then we have another set Q. And Q is defined as Y, such that Y is an integer that is greater than what? 9. Integer again. So greater than 9 would be what? 10, 11, 12, 13, 14, and means it continues. So what are we supposed to be finding here? We are supposed to find W intersect what? Q. So what is W intersect Q? What do these two sets have in common? Well, do we have 5 here? No. 6, no. 7, no. 8, no. 9, no. 10. Yes, we have everything here going on and on would be in this intersection. So it will be 10, 11, 12, 13, 14. But what do you observe? This is basically Q. So I can say here that W intersect Q is basically equals to Q because the set we have right here is basically Q. Good. Okay. So number 2, it says X and Y are two sets. Then using the information given below, find Y. This problem was taken from WAEC 2009. It was problem number 2. So they want us to find the set Y. So one of the approaches to this is to use what we call a Venn diagram. So let's use a Venn diagram. I should put a box around it. There will be some other problem that this box is going to be very, very important. That's the universal set. So now, one of the things you want to begin with, if it is possible, is to begin with the intersection. So this is X, this is Y. So X intercept Y is 20. So that means they have that number 20 in common. So now, let's look at the elements that are in X and the elements that are in, so this is the union there. So these are all the elements in X and Y combined. So let's get some things here. In X, I have 4. All right. I have what? 8. I have what? 12. I have 16. Correct? 4, 4, 8, 12, 16, 20. So those are the numbers that I have already listed. I have listed 4. I have listed what? 8. I've listed 12. I've listed 16. I've listed 20. So the rest of those things would then be the elements that are in Y. What I did, the ones that I left. 5, 10, and what? 15. But remember, 20 is also in Y. So, what is going to be our set Y? Y is going to contain the elements what? 5, 10, 15, and 20. Multiples of 5. Okay? Now, one temptation is to ignore 20. 20 actually belongs to both sets X and Y. So, if you are finding the elements that are in Y, you have to list 20 also. But this was problem number 2. We had very few problems in this section here. We kind of checked the WAEC and there were a lot of questions on this area. So, but these are the basic problems that you're going to find here. Again, we went over things like intersections and unions. Making a Venn diagram and putting those things in can be very useful. Again, thank you very much. This has been a production of FIELD, the Foundation for Equity and Excellence in Education in Liberia. You know, we are committed to provide quality instructional materials. One way we'll be able to do this is when we have the support necessary to improve the quality of our work and to expand our work to other content areas like English, social studies, chemistry, physics, biology, economics, geography. Look, to be able to do that, we need your support. So we are appealing to you. No donation is too small. Please support this course. Please support this initiative by making whatever contribution you can make to www.fieldliberia.org. We appreciate it. Again, don't forget to subscribe to our YouTube channel. Follow us on Twitter. Like us on Facebook, and send us your feedback to fieldliberia2015@gmail.com. Thank you very much.